You're being watched, not by a drone overhead, not by a camera in the corner, but possibly by something so small you can't even see it. Microscopic computers, smaller than a grain of salt, are now capable of collecting data, sending signals, and even tracking movement. And they could be hiding in anything. A wall, a light bulb, a uniform, even your food packaging. Governments are spending billions on this invisible surveillance, and you'll never know it's there. This isn't science fiction, it's next-gen espionage. Let's dive into the world of microsurveillance and how invisible machines may be reshaping the meaning of privacy itself. The era of microscopic computing. In the past, surveillance tech was big, clunky, mechanical, like spy planes lumbering across foreign skies, bugged rotary phones with wires coiled like snakes, cameras jammed into hollowed-out alarm clocks, clicking away in secret. It all required lots of effort, space to install, power to run, a person, or often a team, to monitor and maintain. Surveillance used to feel like an event, a full-blown operation with a van parked nearby and someone eating cold pizza while watching grainy footage. But today, we've crossed a threshold, stepped through a door, and there is no going back. Welcome to the age of smart dust, tiny wireless microelectronic devices, sometimes no larger than a speck of sand caught in your shoe. They're not just cameras or sensors shrunk down to dollhouse size. These are fully functional computers, complete systems equipped with motion detectors, chemical sniffers, thermal readers, sound sensors, plus vibration analyzers, and of course radio transmitters, quietly beam real-time data to a receiver miles away. Currently they are tracking structural stress on bridges, sniffing for gas leaks in remote pipelines, monitoring soil and air quality across farmland, even embedded in military field gear, though nobody officially confirms that. But here's the unnerving part. The very tech used to protect buildings can just as easily watch people. Once scattered, smart dust disappears into the scenery. It clings to walls, settles in carpet fibers, and hides in the folds of your curtains. You won't see it, you won't hear it, and you definitely won't know when it's watching you. It doesn't need to be retrieved. It doesn't leave a trace. It just keeps transmitting. Quiet, constant, invisible. This isn't surveillance with gadgets. It's surveillance as atmosphere, less James Bond, and more of a silent mist of machines. A new chapter in computing, too small to notice, and too powerful to ignore. The military origin story. Smart dust didn't emerge from the sleek campuses of Silicon Valley or the cozy chaos of a hacker's garage. It wasn't a startup pitch, it was a battlefield directive. Back in the 1990s, the US military, through the Defense Advanced Research Projects Agency, quietly launched an initiative that sounded like something ripped from a novel. Smart dust. And the goal? Swarms of microscopic machines that could be scattered across hostile terrain. Invisible sentinels. Always watching, never seen. Floating through the air, settling onto surfaces, embedding into the landscape like digital pollen. These weren't passive sensors. They were meant to listen, to measure, to report back without betraying their presence. 1,000 eyes, the size of dust mites. MMs, micro-electromechanical systems. Tiny machines capable of interacting with the physical world at astonishingly small scales. Suddenly, researchers weren't just asking if it was possible. They were figuring out how to build motion and chemical sensors that function at the millimeter or micrometer scale and power these tiny machines using ambient energy from heat, light, or even vibration, enabling wireless communication without conventional antennas, batteries, or human intervention. By the early 2000s, labs had working prototypes. By the 2020s, those early blueprints had matured into strategic defense technologies, not just theory, not just research. Deployment? The US Department of Defense, the Chinese People's Liberation Army, Israel, Russia, and major military contractors all began investing in microsurveillance systems, not just for deserts and war zones, but for cities. Today, they've developed dust that can float into urban environments undetected. Microsensors embedded into walls, concrete, and even textiles. Networks of smart particles that track motion, record conversations, detect chemicals, and map physical spaces in real time. Surveillance is shrinking to the point of invisibility. The real breakthrough in surveillance wasn't just the miniaturization of hardware, it was the miniaturization of entire systems. Not just smaller parts, smaller everything. In the past, surveillance meant infrastructure. Cameras are bolted to poles, motion sensors are mounted on ceilings, cables running through walls. a central hub, receiving, recording, and monitoring, a whole ecosystem, hardwired and obvious. Now, that entire ecosystem has shattered into fragments. It's dissolved into particles, grains, fibers, dust. Today, surveillance doesn't need to look like surveillance. It lives in the seams of your environment, hiding in plain sight. The real leap forward wasn't just microelectronics. It was miniaturized networking, building a way for microscopic devices to communicate with each other in real time, form self-healing mesh networks that adapt if one node fails, power themselves using ambient light, body heat, or surface vibrations, transmit encrypted data without drawing attention or detection. They're real. Some are already in the field. Take these examples. Neural dust. Microscopic implants smaller than a grain of sand that attach to nerves and muscles, reading electrical signals. Originally intended for medical diagnostics, now being explored for military brain, computer interfaces, and yes, covert surveillance. Smart paint. Not decoration, but detection. Wall coatings infused with nanosensors that can pick up on motion, vibrations even, the subtlest pressure changes. Your wall might be listening. Radio frequency identification tags, so thin they're printable, embedded in packaging, sewn into clothes, broadcasting identity and movement without your knowledge. Magnetometers, ultra-sensitive, extremely small, but capable of picking up footsteps, heartbeat rhythms, or even whispered speech, all from beneath a floorboard or inside a piece of furniture. What used to require a camera and a cable now floats in the air, clings to your clothes, waits in your walls. Surveillance has stopped being a device. It has become an atmosphere, silent, ambient, ubiquitous. You won't see it, you won't feel it, but it's there, everywhere, watching, listening, quietly, permanently, rewriting what private even means. Where it's being used today, you won't find this tech in a glass display case. No sales rep with a name tag asking if you want to bundle it. This isn't consumer tech. It's classified, covert, often deniable. But make no mistake, it's already out there, quietly deployed, deeply integrated into some of the world's most sensitive and strategically vital operations. Start at the borders. Today's border control systems aren't just relying on patrols and cameras. They're embedding ground sensors so sensitive they can pick up on a single pair of footsteps, a faint vibration, a shift in ambient heat, even hushed voices, all of it triggering alerts before anyone's in visual range. Let's move to high-security facilities, nuclear power plants, defense laboratories, and critical data centers. These aren't just protected by fences and guards. They're wrapped in smart paint, not for looks or color. This paint is a sensor network. It feels the difference between a door closing gently and someone applying pressure. It detects vibrations, wall taps, and even minute shifts in air pressure. It gives buildings nerves. Then there's espionage, the shadowy world where everything is speculative and nothing is officially confirmed. But documents leaked, statements buried in testimony, and whistleblowers have pointed to the use of microscopic electromagnetic tags as well as smart dust in tracking foreign diplomats, coating their vehicles, stitching into their clothing, slipping into the spine of a passport, hiding in plain sight. On the battlefield, drones don't just carry missiles. They disperse smart dust across roads, fields, and mountains, invisible tripwires that sense motion, heat signatures, and even underground tunneling. Surveillance no longer depends on a lens. It responds to presence. Covert teams now plant dust-sized sensors into everyday items, such as briefcases, keyboard seams, and phone vents. No need for software hacks, no need for bugs, just constant telemetry, location, movement, interactions, all without a digital footprint. This isn't surveillance by camera, it's surveillance by climate. A digital fog, persistent, pervasive, invisible, and almost impossible to trace. How these devices work. So how do you shrink an entire computer, processor, sensors, power supply, and communications module down to something smaller than a grain of sand? Spoiler, it's not magic. It's high-precision engineering pushed to the absolute edge of what's physically possible. This is computing, distilled to its atomic essence. Each smart dust mote isn't just a sensor, it's a system. Condensed, efficient, discrete, and astonishingly advanced for something you might accidentally inhale. Let's break it down. MEMS chips, short for micro-electromechanical systems, form the sensory core. These aren't generic electronics. They're mechanical structures at microscopic scales, built to respond to the environment. They can detect pressure shifts, respond to light intensity, sense vibrations or motion, and pick up trace chemicals in the air or on the surfaces. Think of them as the moat's sense organs, its microscopic eyes, ears, and nose. Energy harvesters keep the system alive. No AAA batteries here, no charging port. Smart dust draws power from the world around it. Mini solar cells sipping ambient light. Piezoelectric materials that turn vibration into electricity. Thermal scavengers pulling warmth from human skin, engines, or sunlight on a windowsill. Always on standby, always charging, never needing a plug. Micro radios make communication possible. These moats don't shout, they whisper. They piggyback on nearby signals. Wi-Fi, Bluetooth, even ultrasonic sound waves. They bounce data invisibly through the air, passing it quietly to a nearby receiver. Some moats go even further, with neural nets on chip. Tiny machine learning models baked directly into the silicon. They can recognize footstep patterns, distinguish a human voice from background noise, detect a specific chemical signature, flag unusual movement or vibrations. And they're not always active. Many are programmed to wake up only under certain conditions, motion, heat, and certain gases. Self-destruct after a mission, physically breaking down or frying their circuits, as well as camouflage themselves, mimicking natural dust, pollen, or lint. These aren't dumb trackers. They don't just record, they interpret, they act, and then often they vanish. This isn't passive surveillance, it's an intelligent presence, silent, responsive, nearly invisible, and very, very real. This isn't just spying, it's infrastructure. Microscopic surveillance isn't just about spycraft, it's becoming part of the operating system of modern civilization. Governments, cities, and corporations are starting to treat smart dust not as a gadget, but as infrastructure. Imagine roads embedded with microscopic sensors to monitor traffic flow, detect potholes, and analyze vehicle patterns in real time. Office buildings and malls outfitted with dust that tracks how crowds move, identifying choke points, optimizing emergency exits, and even adjusting lighting or HVAC systems based on real-time occupancy. Food supply chains laced with traceable smart particles, able to follow a tomato from farm to shelf and flag contamination sources instantly. Airports and transit hubs outfitted with biosensing dust that can detect pathogens, alerting authorities to a viral threat before symptoms even appear. Pilot programs are already underway in major cities and industrial zones. And while these sensors don't have lenses or microphones in the traditional sense, they still see in their way. They know where you were by pressure patterns and motion trails, when you spoke by vibration and acoustic mapping, if your bag moved through the magnetometer shifts, and whether any unusual chemicals were released into the air. It's not just surveillance, it's real-time environmental awareness, a nervous system for the modern world, watching everything, predicting trends, flagging risks. And like any infrastructure, once it's in place, you stop noticing it, but it never stops noticing you. Who's investing in this and why? Microscopic surveillance is a geopolitical arms race, a data gold rush fought with particles. Around the world, governments and corporations are pouring resources into making sensors smaller, smarter, and harder to detect. In the US, DARPA is funding deployable sensor clouds, smart dust swarms that can spread across a battlefield, city, or critical facility, self-organizing into a living surveillance grid. In China, the Academy of Sciences is working on bio-integrated dust microscopic sensors that could interface with the human body or dissolve safely in the environment, gathering everything from health data to emotional cues. In Israel, the IDF is reportedly testing nano-trackers that can detect perimeter breaches, track individual footsteps, and distinguish between vehicles, animals, and humans, all from particles you'd never see. Lastly, in Russia, the FSB has been linked to the use of microphones, disguised as dust or fabric fibers, planted in embassies and meeting rooms. Private tech giants are also in the race. Cisco is exploring smart dust networks for smart buildings. Intel is working on microprocessors that can function at the dust scale. Siemens is developing industrial-grade microsensors for factories and logistics chains. Because here's the truth. Whoever owns the smallest sensors owns the most precise, continuous, and unobtrusive data. It's not just about spying. It's about dominance over the invisible, the ability to see what others can't, to measure what others miss, to build infrastructure no one notices until it's too late. It's a race to own the invisible layer of the modern world. And it's underway. What are the ethics and risks? With great invisibility comes great potential for abuse. Smart dust doesn't just challenge privacy, it dissolves it. Unlike traditional surveillance tools, these systems operate below the threshold of awareness. Which raises a critical question. If you don't know you're being watched, how can you ever meaningfully consent? The risks are wide-reaching and unsettling. Key concerns include warrantless surveillance by governments or agencies using microsensors to bypass legal oversight, covert implantation, smart dust embedded in clothing, personal items, or even on the body without consent, tracking of protesters, dissidents, or journalists in ways that are undetectable, untraceable, and deeply chilling, corporate espionage, where competitors use dust to monitor meetings, research labs, or executive offices, biological and environmental risk, if devices degrade unpredictably or react chemically with the body or surroundings. No clear legal definition of what qualifies as a search or a seizure when the technology is too small to see. The scariest part? Most governments aren't even fully aware this exists at scale. And the ones that are? They're not all democracies. If authoritarian regimes adopt this tech, forget facial recognition. This is deeper, smarter, scarier. Is there any way to protect yourself? Truthfully? Not really. This isn't turning off a webcam or putting tape over a laptop mic. Smart dust doesn't give that luxury. These microsensors are too small for any off-the-shelf consumer detection tools, designed to blend in, disguised as dust, paint, debris, packaging, or stickers, often dormant until triggered by motion, heat, speech, or vibration. Embedded in objects you'd never think to question, clothing tags, light fixtures, even the seal of your water. So, how do you defend against something you can't see, hear, or feel? Luckily, some potential defenses exist. In theory, Faraday cages can block wireless transmissions, but only if you know what to isolate. Smart dust filters are being developed to trap or neutralize these particles in controlled airspaces. Industrial-scale scanners might one day detect clusters of active modes, but are impractical for everyday life. Legal frameworks could require manufacturers and governments to declare embedded sensors, much like food labeling. But let's be honest, these aren't tools the average person can carry in their pocket, and even if laws are passed, enforcement will always lag behind innovation. For most people, this is a ghost threat. Real, everywhere, invisible. And without your consent, you're not just being watched by cameras anymore. You're being mapped by particles, observed by grains of silicon, tracked by dust. This is the future of surveillance, invisible, ambient, and impossibly small. Like this video and subscribe if you want to stay ahead of the invisible wars shaping our future. Tell us in the comments, how do we protect our privacy in a world that watches silently? Thanks for watching. Stay blessed and stay curious.